everyone. Hey everyone. I'm going to go through this slide with you. We've got one more assignment on Monday, and it's going to be with the same program. And then the next two assignments are just going to catch up with what you need. I hope everybody's doing well. Almost done. Yay. So, okay, I'm going to go ahead and switch screens. Okay, so this is what it should look like, right? Okay. So this is a Phet simulation. You guys have had this for a while. All right, it looks like this. It does look like build an atom if you did complete the build the atom. All right, I'm going to go ahead and open it. There's a few things that you need to do. You can play with either one of these, but this is the one that we're going to focus on the most, okay? All right, I would go ahead and also click on both of those here. Go ahead and play. You can switch in between this. You can switch there. It does some really cool things. Now, once again, when we first came back to the online learning, it looks very similar to build an atom, but it's not. I'm talking about isotopes. And iso means different. And I'm going to go ahead. Iso means different. Tope means type, so a different type of atom. I wish that they had it that way, but it's just the Greek pronunciation. Okay. Alrighty, so let me go ahead and get the other class, get the sheet out. So go ahead. There's a lot of things. You can go to the mixtures. This is what we're going to be doing on day 2. So this is just day 1. Okay, so that you guys could stay there basically. All right. I'm going to go ahead and I'm going to pull up the worksheet. And I think I've got everything here. So I'm going to blow this up. There's a lot of question marks. It's really not too bad. It's very slow. And that's what I thought. I'm going to pause for a second. Okay. I'm going to go ahead and increase size so that you guys can see that. I think that's a little less. There we go. Okay, so you have this. I'm giving you time to read. Okay. All right, let's practice with boron. Okay. I know I'm boroning you guys with chemistry, but yeah, boron's actually pretty cool. It's a cleaning agent. It's above aluminum, so it's a metal, but it's not really a metal. It's kind of crazy. It's a metalloid. So what are the symbols, atomic mass, and abundance of the isotope boron? I'm going to go ahead and click that for you. So we go here. I'm going to go ahead and get it open. So I'm going to click on boron, B, element 5. Okay, so that's what it looks like. Okay, so what's the symbol? I'm going to go ahead and take it off here. When we get done, I'm going to go, oh, where are we? Strange. Okay, B. Symbol, atomic mass would be 5. And abundance in nature, so I have to go look at that. And abundance in nature, oh, right where it's at, 80.1%. In nature of isotope 11. Let me make sure something. if I have boron, and it is 11. Okay, there you go. All right. So now the next part on that is we're going to go down and, oh, each of these go down. Do you see that? We're sometimes used to things going across. If you notice that this symbol is a little wonky, don't worry about that. We're going, I'm just going to be, I just need you to put the symbol. You don't need to make special numbers. So we see it's carbon 13. So I'm going to click here and I'm going to go to carbon. But if you notice that that's carbon 12, I need to make it one more. And oh, I've got carbon 13. And that's from you being able to play with it. Okay? All right, so we have carbon. How many protons? Well, I can go look right here. 1, 2, 3, 4, 5, 6. I can count the neutrons, or 8-man. 6 plus what number equals 13? 1, 2, 3, 4, 5, 6, 7. So I've got 7. How many electrons? 1, 2, 3, 4, 5, 6. 6. Atomic mass. This one's tricky. You're going to have to click it over. Okay? And yes, you need the whole number. Okay? 13.0035. Now, am I going to count you two wrong if you're a little bit mess? Like say that I have 0, 3, 5. Am I going to take off? No. But I need you to try to get as much as you can on there. And maybe I need to change the font on this one, on these, so that you guys can get that. 0, 3. Okay? The abundance is right here. Is it stable or unstable? Well, maybe you don't know, but it does say stable right now. But this is what happens when it looks unstable. But that's carbon 14, which is so cool. So it is stable. Now, I wanted to go over to oxygen, and I need to make oxygen 18. But I need to make it 18, so I throw 2 down. And it does come up with 1. There's one that's a little, so you just write down the numbers, all of them are there. There's one that's a little wonky. Might be this next one. Okay, so you have 0% and you have these dashes. So at the bottom of this one, it doesn't tell you if it's unstable. You see it wiggling. 2, it's 0%. And it doesn't have an atomic mass, so I just put what they have there. Alrighty. So if you have any questions, please holler at me. It's fairly simple, and I will see you guys next week. Bye.